Through the looking glass, light bends and scatters, painting illusions that feel more real than the solid world around us. Imagine standing in a darkened room where a single shaft of sunlight breaks through a crack in the curtains. Dust motes drift lazily in its golden stream, each speck suspended like a tiny planet. The beam strikes a polished surface, and suddenly, another world comes alive inside the glass. A face appears, your own, yet not yours. It blinks when you blink, frowns when you frown, but the eerie perfection of its mimicry raises an ancient question. What exactly is hiding behind that silvered surface? Is it only a trick of optics or a window into something far stranger? The mirror has always carried with it an unspoken mystery. It seems so ordinary, yet it stirs a subtle discomfort, as if gazing too long might reveal something we are not meant to see. In this opening breath of our journey, we step into that unease, guided not only by science, but by story, philosophy, and imagination. The hook is simple yet unsettling. What if mirrors are not passive objects, but active thresholds? What if every reflection is more than imitation, more than a surface bounce of light? What if it is another Earth staring back at us, separated by only the thinnest of veils? Our ancestors might have believed so. To them, a mirror was never just a mirror. It was a shadow catcher, a spirit holder, sometimes even a doorway. For us, with the language of photons, quantum states, and probabilities, the language has changed, but the unease remains. When we look into the glass, are we looking into the familiar world, or into the fractured mosaic of countless possible worlds layered atop each other? This tension between comfort and terror, between explanation and mystery, will guide everything that follows. The cinematic journey begins not with hard equations, but with imagery. A mirror shatters in slow motion, shards tumbling through the air, each one reflecting the same scene from a slightly different angle. In those splinters we glimpse the central theme, multiple perspectives, multiple realities, all contained within a single surface. Just as a mirror splits a beam of light into endless bouncing paths, our story will split into paths of science, philosophy, and imagination, converging and diverging as we explore. Consider how ordinary it feels to check your reflection. You brush your hair, fix your collar, maybe stare at your eyes for a moment longer than you should. Yet behind this ordinariness lurks something profound. That reflection is delayed by nanoseconds, photons bouncing, captured, and returned. In those fleeting instants, reality itself is negotiated. That delay, so small we cannot sense it, contains within it the possibility of something unseen, something unresolved. Quantum physics teaches us that even the smallest intervals, the tiniest exchanges, can carry cosmic weight. If particles can exist in multiple states until observed, what does that mean for the image in the mirror, which seems to exist only when you look at it? This opening passage is not about answers, but about atmosphere. We set the tone of awe, of wonder, of suspicion. A mirror, after all, is not only a surface. It is a symbol of duality, day and night, life and death, self and other, hope and despair. Each time you lean closer to your reflection, you are enacting the oldest ritual in human existence, confronting yourself, while suspecting something else lurks behind the familiar face. We might dismiss these thoughts as poetic exaggerations, yet science urges us not to look away too quickly. Quantum mechanics, the deepest lens we have into reality, already tells us the world is stranger than intuition allows. If particles can tunnel through barriers, if entangled photons can know each other's states across light years, then is it so absurd to wonder whether the simple act of reflection hides deeper mysteries? This is the heartbeat of our story. We will wander through myth and superstition, through laboratory experiments and philosophical puzzles, through terror and wonder. Each step will sharpen a single question. Could mirrors be more than objects of vanity and utility? Could they be echoes of something far larger, something infinite? As the curtain rises on this documentary journey, We invite the viewer to step closer, to look again, and to hold their gaze a little longer than comfort allows. Somewhere in that shimmering surface, perhaps faintly at first, they may begin to sense what has haunted humanity since the first polished stone reflected a human face, that the glass does not merely return our image. It dares us to wonder whether another Earth, another self, another reality stares back, waiting for the moment we finally recognize it. The fear of reflections is older than civilization itself. Long before polished glass, humans found their faces in still pools of water, and in that moment, something unsettling stirred. The shimmering image was alive yet untouchable, familiar yet fragile. One ripple could erase the face entirely, and with it, the sense of self. To ancient eyes, this fragile double was not just a likeness. It was a fragment of the soul, something that could be stolen, trapped, or harmed. Cultures across the world wove mirrors into their mythologies with both reverence and dread. In ancient Greece, the tale of Narcissus warned of the dangers of falling in love with one's own reflection. To gaze too deeply was to risk losing the boundary between reality and illusion, to dissolve into the shimmer of the image until nothing remained. Among the Romans, polished metal mirrors were prized possessions, but carried whispers of bad luck if broken, as though the rupture of a reflection might wound the soul itself. Further east, in Japan, mirrors were objects of sacred power. The Yada no Kagami, the great divine mirror, was one of the 3 imperial regalia, believed to hold the wisdom of the gods. Yet the same sacred power also evoked caution. A mirror did not simply reflect the body, but revealed the true spirit, something that could never be hidden. In China, mirrors were thought to ward off demons because they forced evil spirits to confront their own twisted images. What terrifies us in folklore is not the mirror itself, but the possibility that it shows something we should never see. Among indigenous peoples of the Americas, stories spoke of water or obsidian mirrors as thresholds into other realms. Shamans gazed into reflective stones, believing they could slip between worlds. The mirror became both portal and snare, capable of revealing other realities or imprisoning wandering souls. And in medieval Europe, this tension deepened. Mirrors were tools of divination, scrying glasses in which seers claimed to glimpse the future, but they were also seen as dangerous temptations, gateways through which devils might speak. Why did so many civilizations, across time and distance, converge on the same unease? The answer may lie in contrast. The reflection feels like us, yet it is not us. It moves when we move, yet we cannot touch it. It stares back with eyes that are ours, yet not ours. This uncanny duality unsettles the human mind, forcing us to question what is real and what is imitation. The brain, designed to recognize faces with absolute precision, cannot help but treat the mirrored self as both companion and intruder. The result is unease, all mixed with dread. Even in more recent history, this fear persists in superstition. Breaking a mirror is said to bring 7 years of bad luck, an echo of the belief that mirrors hold fragments of the soul. Covering mirrors during mourning, a practice in Jewish and some Christian traditions, reflects the dread that the newly dead might be trapped in the glass, or that the living might glimpse their own end. These rituals, carried quietly into modernity, remind us that reflections are never only practical. They are portals of meaning. And the myths do not stop with human fear. Folklore tells of beings who avoid mirrors, vampires who cast no reflection because they lack a soul, witches who could use mirrors to ensnare their enemies, and spirits who might become trapped within the silvered surface. These tales paint the mirror as a kind of cosmic judge, distinguishing what belongs to this world from what is not. To step in front of the mirror is to risk exposure, to have one's essence revealed. Here lies the contrast that drives this section. The reflection as both promise and threat. On one side, mirrors offer guidance, prophecy, and divine clarity. On the other, they carry the risk of theft, deception, and possession. Hope versus fear. Revelation versus danger. Humans, caught between awe and terror, never fully trusted what they saw. Science may dismiss these legends as superstition, but they cannot erase the emotional power that reflections still hold. Even now, alone in a dark room, catching sight of your face in a mirror can feel unsettling. For just a moment, it doesn't feel like you. The uncanny weight of myth lingers, whispering that perhaps the ancients knew something we have forgotten. As this chapter closes, the question sharpens. Were these stories merely projections of human imagination, or did they hint at a truth hidden within the physics of reflection itself? If light bends and scatters in ways our ancestors could not measure, could their myths be distorted echoes of a deeper reality, an intuition that mirrors may connect to something beyond? The fear of reflections was not baseless terror. It was a recognition, cloaked in story, that the image in the glass is never just a copy. It is a mystery waiting to be solved. The science of light begins with a story that feels almost magical. Imagine a single beam of sunlight breaking free from the chaos of the sun, traveling across 93 million miles of space, and striking the surface of a mirror in your room. In less than a heartbeat, that photon, born in the furious core of a star, has arrived at your eyes, carrying with it the shape and color of your reflection. What feels like the simplest, most ordinary act, checking your face in the mirror, is in fact the climax of a cosmic journey. Every reflection is a story of light. To understand mirrors, we must first understand what light is. For centuries, philosophers and scientists debated whether light was a wave or a stream of particles. Isaac Newton argued for particles, while Christian Huygens championed waves. Centuries later, quantum mechanics would reveal that both were right and both were wrong. Light is a paradox. It behaves like a wave and a particle depending on how we measure it. It ripples like water across the surface of reality, but it also strikes like a bullet, indivisible and precise. This duality is not a quirk of mathematics. It is the essence of what makes reflection so strange, so alive with possibility. When light meets a mirror, an elegant dance begins. The mirror's surface, coated with layers of aluminum or silver, is smooth at a microscopic scale. Photons approach, and instead of sinking into the material, they interact with its electrons. These electrons absorb the photon's energy for a fleeting instant, then re-emit it back. The result is reflection. The light appears to bounce, carrying with it the image of whatever lies before the mirror. But this is only the visible surface of the process. Beneath it lies quantum chaos, where probabilities swirl, and where the act of reflection becomes more than simple geometry. It becomes a conversation between matter and energy. This process is so familiar we take it for granted. A mirror in the bathroom, a storefront window, a phone screen catching your face. Yet the physics is astonishing. The angle of incidence equals the angle of reflection. This simple rule governs the way beams of light trace paths, forming perfect replicas of reality. The symmetry is mesmerizing, as if nature itself insists on elegance. But symmetry also conceals hidden complexity. Not all light reflects perfectly. Some penetrates, scatters, or shifts. Every reflection, no matter how crisp, is incomplete. What you see is only a fraction of the truth, a filtered version of reality sculpted by physical laws. Here lies the mystery that transforms science into philosophy. If every reflection is partial, filtered, delayed by nanoseconds, what are we actually seeing? Is it a true copy of ourselves or a distorted echo? At the quantum level, light doesn't merely reflect, it interacts with uncertainty. Some photons scatter into directions we will never detect. Some pass through the glass entirely. Some may even entangle with others, their fates woven together beyond our perception. What reaches our eyes is only the portion allowed by chance and probability. Every reflection is thus a curated fragment of reality, not the whole. Consider the metaphor of a hall of mirrors at a carnival. Each surface reflects you, but in distorted ways, taller, shorter, wider, thinner. Science tells us that even the most perfect mirror, polished to atomic smoothness, is still a distortion, still a filter. It is an approximation of truth, not truth itself. And here the contrast deepens. Mirrors promise clarity, yet they also hide complexity. They feel certain, yet they embody uncertainty. Light itself compounds this tension. Traveling at 299,792 kilometers per second, photons carry information at the absolute speed limit of a universe. To see your reflection is to see the past, however minuscule the delay may be. The image you see is never the present, only what was. If you gaze into a mirror in a room filled with multiple reflective surfaces, that delay multiplies, stretching into visible echoes. The further back the light bounces, the further into the past you are looking. In this way, mirrors are not only surfaces of reflection. They are time machines, capturing slices of history and delivering them back to you in ghost-like fragments. The cinematic wonder of this realization lies in its intimacy. Every moment you brush your teeth or glance at your face in a shop window, you are participating in one of the most profound physical processes in the universe. Photons, forged in the core of a star, absorbed and re-emitted by electrons, redirected into your eyes, constructing a fleeting image that feels solid but is anything but. Reflection is not stability. It is a dynamic event, a fleeting miracle repeated billions of times each second. This section builds tension by contrasting the simplicity of experience with the vastness of explanation. We look at mirrors as mundane, but their science opens doors into the strangest corners of reality. They are tools, yes, but they're also symbols. Reminders that every glance at ourselves is built on cosmic laws that stretch from the quantum to the galactic. Behind the comfort of recognition lies the terror of uncertainty. The possibility that reflection is not merely imitation, but interpretation. And so we close with the question that propels us forward. If light itself is paradoxical, if mirrors are filters rather than windows, then what else might be hidden in the process of reflection? Could there be more in the glass than photons bouncing back? Perhaps even echoes of other possibilities, other Earths, waiting for us to notice? Quantum superposition is one of the strangest, most haunting concepts in science, and yet it is also one of the most beautiful. To grasp it, imagine walking into a vast hall filled with mirrors stretching in every direction. You stand at the center, and instantly your reflection multiplies into thousands of copies. Each one looks like you, each one moves when you move, yet each exists in a slightly different frame, seen from a slightly different angle. Now imagine that instead of glass and angles, those countless selves are states of reality. This is the essence of superposition, the possibility that something or someone can exist in multiple states at once, only collapsing into a single outcome when observed. At the quantum scale, particles like electrons and photons refuse to obey the tidy logic of everyday life. Instead of choosing one path, they explore all possible paths simultaneously. Instead of being here or there, they are here and there, both wave and particle, both existing and not existing until forced into decision. This uncertainty is not a flaw in our measurement. It is the very fabric of reality. When we say an electron exists in superposition, we are saying it holds all possibilities inside itself like a tightly wound knot of futures. The human imagination has always flirted with this idea, even before physics gave it language. Myths of twins, doubles, shadows, and spirits may have been subconscious reflections of this truth, that existence might not be singular. Superposition makes this metaphor literal. You, right now, reading this, exist as a fixed individual. But at the quantum level, every atom in your body exists as a cloud of possibilities, hovering across countless outcomes. It is as if, in the invisible depths beneath our skin, we are already multiplied. The most famous thought experiment for illustrating this concept is Schrodinger's cat. A cat is sealed in a box with a mechanism triggered by radioactive decay. If the atom decays, poison is released and the cat dies. If not, the cat lives. Quantum mechanics says the atom exists in both decayed and undecayed states simultaneously until observed. By extension, the cat is both alive and dead, two contradictory realities entangled in one box. Only when someone opens the box does the cat collapse into one state. Though absurd, the image lingers because it mirrors our unease with mirrors themselves. What if the reflection we see is not a single truth, but one possibility among many, collapsed by our gaze? Imagine standing in front of a mirror under this lens of superposition. The you in the glass may not be a passive image at all, but one outcome among countless possible versions of yourself. Perhaps another reflection shows the version of you who made a different choice years ago. Another shows a self that succeeded where you failed, or failed where you succeeded. Another shows a self who turned left instead of right, who spoke instead of staying silent, who lived instead of dying. In the silent gleam of the mirror, the idea of superposition becomes personal, no longer confined to subatomic particles. The tension in this idea lies in contrast. On one hand, superposition fills us with awe. We are not trapped in one rigid destiny, but surrounded by infinite variations of possibility. On the other hand, it terrifies. If countless versions of ourselves exist, who are we really? Are we the single one we recognize, or just the one collapsed by the act of looking? The self becomes fragile, flickering like a candle flame in a hall of wind. Experiments bring this strangeness into sharp relief. When scientists fire electrons through a double-slit apparatus, the particles behave like waves, passing through both slits at once and interfering with themselves. They do not commit to one path until observed. Observation alone forces them into choice. It is as if the universe waits for witnesses, refusing to reveal a single truth until compelled. If particles behave this way, why not the larger systems they compose? Why not us? The implication is dizzying. Reality itself may not be fixed until it is observed, and observation may be the act that kills the infinite in favor of the singular. Now return to the mirror. Every time you look into it, you collapse one version of yourself into existence. The others remain hidden, suppressed, reflected only in silence. What if the reflection you see is not a faithful image, but the universe's choice of you among infinite candidates? And what if, in rare moments, the glass falters, revealing a glimpse of one of the others? The you who never walked away from a love, the you who took the risk, the you who died young. Superposition opens the door to these haunting possibilities, blurring the line between science and existential dread. Philosophers have long wondered whether identity is stable or fluid, whether the self we carry through life is a solid structure or a shifting mosaic. Superposition suggests the latter. It suggests that every decision we make is not the closure of possibility, but the birth of countless new realities in which the alternatives continue to live on. The mirror, then, becomes a metaphor for this branching. Each reflection is not just a copy, but a possibility, one version staring back from the depths of quantum potential. Yet science itself admits limits. We cannot directly see superposition at the human scale. Decoherence, interaction with the environment, forces systems like us to collapse into stability. Still, the principle whispers beneath the surface, a reminder that our ordinary world may be built upon extraordinary foundations. What we see in the mirror may not be the whole story. The emotional power of superposition lies in its unresolved nature. It offers both liberation and despair. Liberation, because it implies we are not confined to a single thread of existence. Despair, because it suggests the we know is only one of countless selves, fragile and perhaps meaningless in the vast swarm of possibilities. It is the ultimate contrast, freedom versus insignificance. As this section closes, we are left with a provocative image. The mirror not as a simple reflection, but as a quantum stage, where countless versions of ourselves shimmer in silence, waiting for the act of looking to decide which one we will become. The question lingers like a whisper from the glass. Are you seeing yourself, or just the version that survived observation? The story of the double-slit experiment reads like a riddle told by the universe itself. Imagine a darkened laboratory, silent except for the hum of equipment. At the far end of a room stands a wall with two narrow slits cut into it, side by side. A beam of light is directed toward the wall, and behind it, a screen waits to catch whatever passes through. To the untrained eye, the setup looks trivial, almost childish, like a child's game of shining a flashlight through cracks. Yet what unfolds in this experiment is among the most disturbing, beautiful, and cinematic revelations in all of science. At first glance, the outcome seems obvious. If light is made of particles, tiny bullets of energy, then firing them at two slits should produce two neat bands on the screen, one behind each slit. If light is instead a wave, then the two slits should act like two stones dropped into water, sending ripples that overlap and interfere. In that case, the screen would show not two bands, but a whole pattern of light and dark stripes, an interference pattern born from the overlapping waves. The question is simple. Is light a wave or a particle? When the experiment was performed, the answer was stranger than anyone expected. With both slits open, light created interference patterns, behaving unmistakably like a wave. But when scientists tried to measure which slit the photons went through, the pattern vanished. The moment they observed, the photons collapsed into particle-like behavior, leaving behind two neat bands. Observation alone determined reality. Without observation, light traveled through both slits at once, interfering with itself in a state of quantum superposition. With observation, it chose one path, becoming definite. The universe, it seemed, cared whether someone was watching. This discovery shook science to its core. It wasn't just about light. Later, when electrons, tiny building blocks of matter, were fired through the slits, they too formed interference patterns, behaving like waves when unobserved and like particles when watched. Even individual electrons, fired one at a time, gradually built up interference over time, as if each electron traveled through both slits simultaneously and interfered with itself. How could a single particle be in two places at once? The implication was clear. The act of measurement, of observation, changes the very nature of reality. Now imagine this not as a sterile experiment, but as a scene reflected in a mirror. You stand before the glass, and the photons bouncing off your face behave like those in the double-slit test. They exist in countless possible paths until the moment they're captured by your eyes, collapsing into one image, your reflection. The mirror becomes the screen, and you, the observer, are the experimenter. This parallel transforms a laboratory puzzle into an intimate question. What are we collapsing into existence each time we look into a mirror? The emotional tension here is immense. On one hand, the experiment offers awe. Reality itself seems participatory, as though the universe is an unfinished script waiting for observation to ink the words onto the page. On the other hand, it evokes dread. If reality is only decided when we look, what lies behind the curtain of the unobserved? A world of infinite possibility? Or nothing at all, a void without witness? Physicist Richard Feynman once said the double-slit experiment contains the only mystery in quantum mechanics. It reveals a contrast between intuition and truth so sharp it borders on the absurd. In everyday life, a ball must travel through one hole or the other. But at the quantum level, the ball becomes a wave of probabilities, and only our act of looking forces it to decide. Reality is not solid, but slippery, dissolving into clouds of uncertainty until forced into form. For philosophers, this revelation reignites ancient debates. Do we discover reality, or do we create it by observing? Is the universe a grand machine operating independently of us, Or is it an unfolding stage, awaiting its audience? The double-slit experiment seems to suggest the latter, and that possibility carries both exhilaration and terror. It empowers us, hinting that consciousness may be central to existence. Yet it also undermines our sense of stability. If reality flickers and bends depending on whether it is observed, then perhaps the world we take for granted is less secure than we imagine. To drive the point home, picture the interference pattern glowing softly on the screen in the experiment's darkness. Each band of light and shadow whispers of a reality in which particles traveled every path, touched every possibility. Now picture yourself before a mirror, where every photon carries that same ambiguity, where your reflection is a collapse of infinite versions of yourself into a single outcome. The mirror becomes less an object and more a question. Which version of you does it show, and which remain hidden in the shadows of unobserved probability? The suspense of the double-slit experiment lingers because it never truly resolves. It does not tell us why observation changes reality. It only reveals that it does. This unresolved tension is what keeps scientists awake at night, and what haunts anyone who dares to think too long about it. It suggests that the universe is both richer and stranger than we can comprehend, that behind the curtain of certainty lies a shimmering ocean of possibilities. And so this section closes with a chilling hook. When you glance at your reflection, are you collapsing probabilities into a single self, or are you glimpsing the ghostly interference of countless versions of you that might have been? In the silence of the glass, perhaps the universe is asking you the same question it asks in the lab. What is real when no one is watching? Mirrors are objects we think we understand. Smooth, reflective surfaces that bounce light back to our eyes. Yet when physics steps closer, the simplicity begins to dissolve. At the level of everyday experience, a mirror feels like a barrier. Light strikes, light reflects, and the image is trapped on the surface. But at the quantum level, boundaries are not absolute. What appears to be a wall may be a threshold, and what feels like a separation may, in truth, be a bridge. This is the paradox of mirrors in quantum mechanics. They both divide and connect, both conceal and reveal. To see how this paradox unfolds, we begin with the photon. A photon is not merely a particle of light. It is a messenger carrying information about the universe. When it strikes a mirror, the interaction seems simple. The photon is deflected back, conserving its angle, producing the clean geometry of reflection. Yet in truth, there is no guarantee of where the photon will go. Quantum theory tells us that each photon has probabilities of reflection, transmission, or absorption. The mirror does not simply bounce the photon back. It forces the photon into a lottery of possibilities. Each reflection is not a certainty, but a roll of the dice hidden beneath the surface of reality. This uncertainty grows stranger when mirrors are used in quantum experiments. One of the most haunting devices in physics is the beam splitter, a kind of half-mirror that reflects some photons while letting others pass through. Place one photon before it, and the rules of probability take over. In classical thinking, the photon must choose, reflect, or pass through. But in quantum mechanics, the photon does both. It exists in a superposition of states, traveling along both paths simultaneously. Only when we measure it does it collapse into one choice. The mirror is no longer a simple surface. It becomes a gateway that divides reality into multiple strands. Imagine this in cinematic terms. A single ray of light hits a mirror and splits, not into two visible beams, but into two invisible possibilities, each carrying a version of reality. One path continues forward, the other bounces aside. In one universe, you see the reflection. In another, perhaps hidden from your perception, the photon continues unreflected. Both outcomes are real, but only one is revealed. The mirror thus plays the role of cosmic storyteller, hiding half the tale from us while delivering only one ending to our eyes. This duality gives rise to extraordinary consequences in experiments such as the Mach Zinder interferometer, where mirrors direct photons along two possible routes. When the paths are recombined, interference patterns emerge, as if the photon had traveled both routes at once and interfered with itself. But when detectors are placed to watch which path the photon took, the interference vanishes. The act of observation collapses the mirror's ambiguity into a single, prosaic outcome. This is the observer's dilemma written into glass. Mirrors hold the potential for multiple realities, but only one is revealed when seen. On a deeper level, mirrors are not merely reflectors, but boundaries of quantum fields. They constrain how light waves oscillate, forcing them into standing patterns, much like a plucked guitar string bound by its ends. In quantum electrodynamics, this effect creates the so-called Casimir force, a mysterious attraction between mirrors placed very close together in a vacuum. Empty space itself, the quantum vacuum, seethes with fluctuations of energy, and mirrors alter that invisible froth, creating measurable forces out of nothingness. What appears as stillness in the glass hides a restless sea of possibility, one that mirrors both shape and reveal. Here the contrasts sharpen. On one side, mirrors feel solid and dependable. They give us clarity, symmetry, self-recognition. On the other, they conceal the quantum strangeness of boundaries that are not really boundaries, of surfaces that are also portals. The ordinary bathroom mirror becomes a symbol of uncertainty, a surface that plays by rules we cannot directly see but are forced to inhabit. Behind its shine lies not stability, but mystery. And what of us, the observers? Each time we face a mirror, we participate in this quantum drama. The photons striking your face scatter in every direction, some absorbed, some reflected, some lost forever. Those reflected toward the mirror strike its surface and split into possibilities, some bouncing back, some tunneling through, some vanishing into heat. The reflection you see is not inevitable but chosen, collapsed out of countless probabilities. When you meet your own eyes in the glass, you are witnessing only one outcome among many hidden ones. The rest vanish into silence, unmeasured, unobserved. There is something almost unsettling in this. We rely on mirrors for certainty, to tell us if we are presentable, to reassure us that we exist in the form we expect. Yet science whispers that mirrors are tricksters, offering not certainty but probability dressed as clarity. The reflection is not guaranteed. It is a resolved question, one that could have been otherwise. How much stranger it becomes, then, to imagine that mirrors might not just reflect photons, but entire versions of ourselves, some hidden, some revealed, each flickering at the edge of possibility. The cinematic tension builds as we imagine a room of infinite mirrors, photons ricocheting endlessly, splitting into countless outcomes. Each bounce is a fork in the road, a branching of worlds that we cannot perceive. The mirror becomes not an end point, but a crossroads, where reality divides and recombines in silence. What looks like a flat surface may be a quantum labyrinth, folding countless paths into a single gleam of light. This section leaves us with a haunting image, a mirror shimmering not as a surface, but as a boundary trembling with invisible choices. When you stand before it, you are not looking at a simple copy. You are standing at the edge of probabilities, watching one version of yourself rise from the glass while others remain forever hidden. The mirror is both barrier and bridge, both surface and portal. The question it leaves us with is unsettling. If mirrors can split photons into parallel possibilities, might they also split realities into parallel Earths? The many worlds interpretation is one of the most audacious ideas ever proposed in physics. It dares to say that every decision, every flicker of possibility, does not vanish into nothingness, but branches into reality. Each outcome that could happen does happen, but not here, not in this world. Instead, it unfolds in a parallel Earth, equally real, equally alive, separated from us by an unbridgeable quantum veil. This is not mythology, not fantasy, but a serious interpretation of quantum mechanics, first introduced in the 1950s by physicist Hugh Everett III. His suggestion was radical. The universe does not collapse into a single outcome when observed. It branches. It multiplies. It becomes infinite. To understand this vision, imagine standing before a mirror once again. You raise your hand, and your reflection raises its hand in perfect synchronization. In our familiar view of reality, there's only one you, one reflection, one timeline. But under the lens of the many-worlds interpretation, the act of raising your hand does not collapse into one version. Instead, every possible action you could take splits into its own universe. In one Earth, your hand rises. In another, it stays still. In another, perhaps imperceptible, but no less real, your hand trembles halfway. All possibilities exist, and all are realized. The mirror, then, is no longer just a reflection of the present. It becomes a metaphor for the endless branching of reality itself. The power of this idea lies in its contrast. On one side, it offers a dizzying kind of hope. If every possibility exists, then somewhere out there, another you achieved what you could not. Somewhere, the book you never finished was completed, the relationship you lost was saved, the dream you abandoned was fulfilled. Every regret becomes an alternate triumph in another world. Yet on the other side, the idea drips with dread. If every possibility exists, then somewhere or another you made a mistake that destroyed everything. Somewhere, the people you love suffered fates you can scarcely imagine. Infinity holds not only salvation, but endless horror. Everett's interpretation arose from the puzzle of quantum mechanics itself. In the Copenhagen interpretation, reality collapses into one outcome when observed. The wave of probabilities is reduced to a single fact. But Everett rejected this collapse. He argued that the wave function never collapses at all. Instead, it continues to evolve, branching into countless worlds where every possibility is realized. What we perceive as collapse is merely our consciousness following one path of the branch. All others continue without us. Think of a river splitting into countless streams. You float along one channel, unaware of the others, yet each flows with equal force. You cannot see the other streams, but they exist, carrying versions of you who made different choices. The multiverse, under this interpretation, is not a fanciful thought experiment, but a natural consequence of quantum equations. The math demands branching. The strangeness lies not in the theory, but in our limited perspective. The imagery of this branching universe is hauntingly cinematic. Picture an endless forest at night, every tree splitting into two, then into four, then into infinite directions. Each branch represents a universe, each leaf a life. Now place a mirror at the forest's center, reflecting not one world, but billions layered upon billions, shimmering faintly like ghostly echoes. To stand before that mirror would be to sense the overwhelming enormity of whatever it suggested, that the universe is not one, but infinite. For centuries, humans have told stories of alternate selves, doppelgangers, parallel worlds, shadow lives. These myths may have been intuitive expressions of the same unease Everett formalized in physics. His proposal turned those shadows into mathematics, those myths into interpretations of experiments. The many worlds interpretation resonates not only with science, but with something primal in the human imagination, the suspicion that we are not alone, not even with ourselves. But the interpretation also forces us to confront unsettling questions about identity. If infinite versions of you exist, are you still unique? Does your life hold meaning? Or are you merely one thread among infinite copies? The hope of infinite chances collides with the despair of infinite insignificance. Perhaps your triumphs matter less if countless other versions of you failed. Or perhaps they matter more because in this world, this one fragile branch, it is your choices that define reality. This contrast between hope and dread makes the many worlds interpretation more than a scientific theory. It becomes a philosophical crossroads. It asks us to consider whether our actions ripple infinitely or vanish into irrelevance. It forces us to question whether morality, responsibility, and meaning can survive in a cosmos where everything that can happen does happen. Do our choices matter more because they are real here, or less because they are inevitable somewhere else? The cinematic weight of this idea lingers when applied to the mirror itself. Each time you gaze into your reflection, imagine that the glass does not simply return one image, but holds within it infinite others. The reflection you see is only the one chosen by the path you are on. Behind the surface, invisible to you, are other versions, some smiling when you frown, some crying when you laugh, some not there at all. The mirror becomes a metaphor for the unseeable vastness of the multiverse, a silent reminder that the self you recognize is one of countless selves that will never meet. As this section closes, the narrative leaves us with the same question that haunted Everett's life. If every world exists, why do we only perceive one? Are we prisoners of our branch, bound forever to one reflection? Or might there be cracks in the mirror of reality, moments when the glass thins and we glimpse the shimmer of other Earths waiting just beyond? The answer remains hidden, but the possibility reshapes everything. That the universe is not a single story, but an infinite library, and we are merely reading one page at a time. In a vast landscape of physics, there is a realm stranger than science fiction and more haunting than myth: the quantum vacuum. At first glance, it sounds like nothingness, an emptiness beyond emptiness, a perfect void where neither matter nor energy exists. But modern physics reveals a shocking truth. What we call nothing is not empty at all. It is alive with invisible activity, restless, ceaseless, a stage where ghost-like particles flicker in and out of existence. This seething undercurrent of reality is not metaphorical. It is measurable, it is real, and mirrors have the power to shape it. To understand the paradox of the quantum vacuum, imagine staring into the night sky. Between the stars, you might think there is vast black emptiness, a cosmic silence stretching without end. But on the quantum scale, that silence is roaring. Space itself is never still. Energy fields fluctuate endlessly, birthing virtual particles in pairs, one particle and one antiparticle, that annihilate almost instantly, vanishing before they can be observed. Yet in their brief dance, they leave subtle traces, and those traces shape the universe we live in. Now place two mirrors in this restless void, positioned very close together, separated by only a hair's breadth. What happens is astonishing. The mirrors alter the vacuum itself. They force the energy fluctuations between them into specific patterns, like strings on a violin being pinned at the ends. Outside the mirrors, the vacuum still seethes freely, but between them, certain wavelengths cannot exist. This imbalance creates a measurable force, drawing the mirrors together as if an invisible hand were pressing them inward. This effect is called the Casimir force, a silent, ghostly attraction born not of matter, not of light, but of the energy of nothingness itself. The Casimir effect is one of those phenomena that sounds impossible yet has been experimentally confirmed. Tiny plates placed nanometers apart are indeed drawn together, proving that the void is not empty. The nothing we thought we knew is actually a something, strange, unstable, humming with possibility. And mirrors are the tools that reveal it. With their reflective surfaces, they reshape the structure of the vacuum, exposing forces that would otherwise remain hidden forever. This discovery alters the very way we think about reality. If emptiness is not empty, then what is the true fabric of existence? If the vacuum is alive, then perhaps it is not a background for the universe, but the foundation of it. Cosmologists even suggest that the birth of the universe itself, the Big Bang, was triggered by fluctuations in this quantum vacuum. The nothingness gave rise to everything. Out of ghostly particles came galaxies, stars, Earth, and life itself. In this light, mirrors are not just passive reflectors of light. They are instruments that let us glimpse the raw, trembling heartbeat of creation. The imagery is cinematic. Picture two mirrors suspended in darkness, facing each other in the void. No light shines, no sound moves, and yet, in that silence, a force is born. Invisible particles bubble in and out of being, like whispers in the dark. The mirrors draw closer, not by magic, but by the rules of quantum mechanics. The vacuum, once thought to be empty, reveals itself as a wellspring of hidden power. It is a reminder that what we cannot see may be more powerful than what we can. There is also a philosophical weight to this revelation. For centuries, philosophers and mystics have debated the nature of nothingness. Is the void truly absence, or is it a hidden fullness? Quantum physics now leans toward the latter. The void is not barren, but fertile, a cosmic womb of possibility. In this interpretation, emptiness is the ultimate paradox. It is not the end of being, but the ground from which being emerges. The mirror, once more, becomes a symbol. It shows us what we see, but it also teaches us that the unseen is just as real, perhaps more so. This discovery unsettles as much as it inspires. If the vacuum is alive with fluctuations, then reality is not solid but trembling, not stable but always on the edge of change. The ground beneath existence is not firm. It is quivering, uncertain, filled with invisible storms. The mirror's role in revealing this chaos becomes deeply symbolic. We rely on glass to give us clarity, yet here it exposes only mystery. The reflection is certainty, but the force behind it whispers of instability. The Casimir effect also teases at technological horizons. Some have speculated about harnessing vacuum energy, tapping into the restless fluctuations of nothingness as a limitless source of power. If achieved, such mastery would change civilization forever. But the vacuum resists capture. It is like trying to net the wind, like grasping at shadows. Still, the possibility lingers, shimmering like a mirage, that mirrors might not only reflect our image, but one day unlock the hidden energy of the void itself. As we leave this chapter, the image that remains is one of contrasts. Emptiness that is not empty, silence that roars with energy, mirrors that reveal invisible forces pressing in from the dark. It forces us to ask, if the vacuum itself is alive, then what else might be concealed in its depths? Could there be not just energy, but entire realities folded within the trembling skin of nothingness? Might the mirror not only expose the vacuum's hidden power, but also, one day, show us the flicker of other Earths trembling within it? When scientists first looked into the quantum world, they did not expect to encounter the idea of parallel universes. Yet again and again, experiments began to hint that our reality might not be singular. At the center of this mystery stands one of the most famous and haunting experiments in all of science, the double-slit experiment. It is simple in design, yet unravels the very fabric of how we understand existence. With only light, a pair of slits, and a screen, this experiment forced us to confront a truth stranger than fiction, that particles behave like waves, waves behave like possibilities, and observation itself can change reality. And within its shadows, some physicists began to glimpse a deeper possibility, that mirrors and reflections may not simply bounce light back to us, but could be thin veils between branching worlds. Picture the setup. A beam of light, or even a single photon, is aimed at a barrier with two narrow slits. On the other side of the barrier is a screen, waiting to record where the light lands. In classical thinking, the photon should behave like a tiny bullet, passing through one slit or the other, leaving two bands of light on the screen. But this is not what happens. Instead, what appears is an interference pattern, alternating bright and dark stripes, the signature of waves overlapping, as though each photon passed through both slits at once and interfered with itself. A single particle behaving like many, a single event unfolding in multiple possibilities. The strangeness deepens when we try to watch the process. Place a detector at the slits to see which path the photon takes, and the interference pattern vanishes. The photon collapses into a single path, leaving behind only two bands instead of many. The act of observation reshapes reality. It is as though the universe itself refuses to reveal its deeper mysteries when watched too closely. And yet, without measurement, the quantum world behaves as if many paths, many possibilities exist simultaneously. This experiment has been repeated countless times with not only light but electrons, atoms, even molecules. Each time, the results are the same. The quantum world holds its possibilities in superposition until observation collapses them. The double slit is more than a physics demonstration. It is a portal into the philosophical abyss. If reality behaves as if multiple versions of events exist simultaneously, could it be that each possibility is not erased but realized in some other universe? Could the interference pattern itself be a shadow of worlds unseen? Here, mirrors enter the stage once more. In many variations of the experiment, mirrors and beam splitters are used to direct photons along multiple possible paths. These mirrors divide and recombine light, producing interference not from separate beams, but from the same photon exploring parallel routes. In one interpretation, the photon is not splitting at all. Instead, it is traveling in multiple universes simultaneously, with mirrors acting as gateways that align those realities for a fleeting instant. When the photon interferes with itself, perhaps it is not one photon in one universe, but multiple versions across multiple Earths, colliding in a dance that we can only glimpse through patterns on a screen. The cinematic imagery is staggering. Imagine a photon leaving a source and splitting at a mirror, traveling down two paths. In one universe, it takes the left path, in another the right. Both exist, both unfold, and the interference pattern is the signature of their silent meeting. To us, it looks like waves overlapping, but in truth, it could be worlds overlapping, their echoes shimmering in light and shadow. The mirror, then, is no longer just a reflector of images, but a crossroad where realities touch. This perspective connects directly with the many worlds interpretation. Instead of collapsing into one outcome, the photon continues in every possible path, each in its own branch of reality. The interference we see is the visible consequence of those branches still connected, still whispering to each other through the thin skin of the quantum world. The double-slit experiment thus becomes not just an oddity of physics, but evidence. Controversial, unsettling evidence that our universe may be one of countless others, separated only by the fragile mirrors of probability. The emotional impact of this possibility is profound. On one side, wonder surges. If experiments in tiny labs can hint at other Earths, then perhaps our deepest questions, are we alone? Is there another version of me? Are not just philosophical musings, but scientific realities. The idea ignites awe, that with only light, glass, and observation, we can touch the edge of infinity. On the other side lies fear. If every outcome exists, if universes overlap unseen, then reality is not stable but fractured, branching endlessly. The certainty we cling to of identity, of cause and effect, of a single unfolding timeline, dissolves into mist. Philosophers have long been fascinated by the double-slit experiment because it forces us to confront the power of the observer. Why should looking at a photon change the way it behaves? Why should reality care whether we are watching? If mirrors and detectors can shift the balance of worlds, then perhaps consciousness itself plays a role in weaving reality. The unsettling thought arises. Are we not only participants, but creators, collapsing possibilities into the world we call home, while countless other versions slip away into darkness? This question lingers as we look at the simple imagery of two slits, a screen, and a few mirrors. It seems too small, too ordinary, to contain revelations about the nature of the cosmos. Yet in those shadows lies the possibility that every photon we send through the experiment does not just choose a path, but creates a world. That the interference pattern we marvel at is not a trick of light, but the faint, ghostly trace of universes beyond our own. As this section draws to a close, the mirror returns as the symbol it has always been, a thin surface between what we see and what remains hidden. In the double-slit experiment, mirrors redirect photons into paths we cannot follow, into choices we cannot fully perceive. And yet, the results on the screen whisper that those paths are not lost, not destroyed, but alive elsewhere. The question remains, are we merely watching light play tricks, or are we, in truth, watching other Earths shimmer just beyond the veil? In the long, strange history of science, there are moments when the boundary between experiment and imagination begins to blur. Mirrors, so ordinary in daily life, have become instruments of the extraordinary in laboratories across the world. They are no longer confined to reflecting our faces or decorating our walls. They are precision tools used to probe the very limits of reality. Nowhere is this clearer than in the realm of quantum optics, where mirrors guide, split, and recombine photons in experiments designed to test the deepest questions of existence. Among these experiments, thought experiments like Schrödinger's cat and Wigner's friend collide with real laboratory setups, creating a theater where mirrors play the role of silent actors on a cosmic stage. To grasp this strange union, consider the famous paradox of Schrödinger's cat. Imagine a cat sealed inside a box with a radioactive atom, a vial of poison, and a mechanism triggered by the atom's decay. According to quantum mechanics, the atom exists in a superposition of decayed and undecayed states until observed. This means the cat, tied to the atom's fate, is simultaneously alive and dead, an impossible image to picture, yet unavoidable in the mathematics. The paradox was designed to highlight the absurdity of applying quantum mechanics to the macroscopic world. But mirrors bring this abstraction closer to reality, because in a lab, photons themselves can be placed into superpositions, and mirrors become the dividing lines that send them into overlapping fates. In experiments with beam splitters, essentially half mirrors, photons face a choice. They may pass through or be reflected. But in quantum mechanics, they do both. One path might lead to a detector that kills the photon, while the other allows it to continue unscathed. In this setup, each photon is the cat, both alive and dead until measured. The mirror becomes the box, holding hidden outcomes that we cannot see until we open it. Suddenly, Schrödinger's paradox is not only a metaphor, but an experiment playing out in laboratories, with mirrors channeling the ghostly duality of existence. The strangeness deepens with Wigner's friend, another thought experiment that pushes the paradox further. Imagine a scientist, Wigner's friend, observing a quantum event inside a sealed lab. From a friend's perspective, the measurement has already collapsed into one outcome. Yet for Wigner, outside the lab, the entire friend plus system is still in superposition until he observes it. Reality fractures. Two perspectives, both valid, both irreconcilable. Which is true? Does collapse occur when the photon meets the mirror, when the detector clicks, when the friend observes, or only when Wigner himself becomes aware? Here again, mirrors serve as instruments of division. In quantum optics experiments, a photon can be split into multiple paths, some interacting with detectors, others recombining to create interference patterns. Depending on how the setup is arranged, the photon behaves as if collapse happened at one stage, or not at all. The placement of mirrors dictates the story reality tells. They decide whether outcomes appear mutually exclusive or mysteriously entangled. The mirror is not passive. It sculpts the experiment's narrative, deciding whether we see one world or many. The imagery is cinematic. Imagine a dark laboratory filled with delicate mirrors, angled just so, directing invisible photons into paths thinner than a human hair. Each reflection is a decision point. Each beam splitter a crossroads of destiny. The mirrors remain silent, polished, inhuman, Yet through them, entire paradoxes of existence are staged. To the naked eye, the setup might look like an arrangement of glass and metal. But to the physicist, it is a stage on which the universe reveals its contradictions. What makes these experiments haunting is not only their strangeness, but their implications for us. If Schrödinger's cat and Wigner's friend are more than thought experiments, if mirrors can place particles into superpositions and sustain paradoxical states, then what does this say about our own lives? Are we, too, in some sense superposed until observed? Are our decisions branching endlessly like photons bouncing between mirrors into lives we will never know, but which still exist in parallel? This contrast, the everyday ordinariness of mirrors versus their role in experiments that fracture reality, creates emotional tension. On one side, wonder blooms. Simple tools allow us to glimpse truths usually reserved for philosophy or myth. On the other side, unease creeps in. Reality itself may not be as stable as we thought, but a fragile theater that depends on observation. The mirror becomes an accomplice in this fragility, a surface where certainty dissolves into probability. Even more unsettling is the role of consciousness in these experiments. Schrödinger's cat and Wigner's friend both circle around the same question. Does reality exist independent of observation, or is it brought into being by it? If a mirror can split a photon into two possibilities, and both persist until someone looks, then perhaps the act of looking is not passive but creative. The observer, by choosing a path through mirrors, might be choosing the very universe itself. In modern laboratories, variations of these thought experiments continue to be tested with real particles. Researchers place detectors at different stages, remove mirrors, or add them back in to see how interference patterns change. Sometimes the results suggest collapse happens early, sometimes late, sometimes not at all. The ambiguity refuses to resolve, as if the universe is guarding its deepest secret. Yet the role of mirrors remains central. They're the gates through which photons pass into paradox, and the tools that allow us to glimpse the hidden scaffolding of reality. As this section closes, we are left with the image of a mirror gleaming in the dark, silently dividing a photon into overlapping fates. In its surface lies the paradox of the cat, alive and dead, and the puzzle of Wigner's friend, collapsed and uncollapsed. Mirrors thus become more than reflectors. They're instruments of metaphysics, devices that force us to confront the question we cannot escape. Does reality exist independently, or is it woven only when observed? And if mirrors can hold such paradoxes within their shine, then perhaps every reflection we see is itself a silent paradox, a reminder that what looks solid may in fact be trembling with invisible possibilities. Quantum entanglement has often been called spooky action at a distance, a phrase borrowed from Einstein, who could never quite accept its eerie implications. At its heart, entanglement is a phenomenon in which two particles, photons, electrons, or even larger systems, become linked so deeply that their fates remain connected no matter how far apart they travel. Measure one, and you instantaneously know the state of the other. It is as if the particles share a hidden script, an invisible tether stretching across the cosmos. And here, once again, mirrors play a vital role, not as simple reflectors, but as conduits that split, direct, and recombine photons in experiments designed to expose the hidden web binding reality together. To visualize entanglement, imagine creating a pair of photons in a laboratory. Using a special crystal, a single photon can be split into two, their properties forever linked. Send one photon toward a detector in one direction and the other down a separate path. No matter how far the second photon travels, even if one is on Earth and the other near the moon, the moment you measure the first, the second is instantly set. It defies our everyday sense of space and time. Communication, as we know it, requires signals moving at finite speeds. But entanglement seems instantaneous, ignoring distance, ignoring delay, connecting the two as if they were still one. Mirrors are the silent architects of many such entanglement experiments. In setups like the famous Bell test experiments, mirrors and beam splitters are used to direct entangled photons into different paths, sending them toward detectors kilometers apart. The angles of these mirrors, their subtle placements, dictate how the photons are steered. They decide whether interference patterns appear, whether correlations can be measured, and whether the invisible connection holds up under scrutiny. The mirror becomes more than glass. It becomes the stage director of reality's hidden script. The results of these experiments are as unsettling as they are profound. Time and again, entangled particles behave in ways that defy local realism. The idea that objects have definite properties independent of measurement, and that no influence can travel faster than light. Entanglement shatters this classical worldview. It suggests that at the deepest level, reality is not composed of isolated parts, but of interwoven threads. Particles are not separate actors, but notes in a single cosmic chord. Mirrors, by splitting and guiding light, allow us to hear this chord resonate in the laboratory. The cinematic imagery is powerful. Imagine two photons born together in a flash of light. One bounces off a mirror and races into one direction. The other takes a different path. They may be separated by walls, by oceans, even by planets. And yet, when one photon is measured, the other responds instantly, as if the mirror's reflection was never broken. There are two sparks flickering across the void, tied by an invisible cord that no barrier can sever. The mirror becomes the first split in their journey, the point where one world becomes two, and yet the two remain one. The emotional resonance of entanglement lies in its paradox. On one side, there is awe. The universe is not fragmented, but holistic, each part connected to every other in ways that defy distance. This vision fills us with wonder, suggesting that separation may be an illusion, that everything is bound together in a web of unseen unity. On the other side, there is unease. If information can spread instantly, faster than light, then what does this say about causality? About free will? About the very structure of space and time? Entanglement does not merely stretch our imagination. It fractures the foundations of our understanding. Philosophically, entanglement invites us to reconsider the nature of individuality. If particles can be linked across the universe, then perhaps separation itself is only surface deep. Perhaps mirrors, by splitting and guiding photons, are revealing not just connections between particles, but connections between worlds, between versions of ourselves. Could entangled reflections hint at parallel Earths, each linked to the others, shimmering across the quantum web? The idea is unsettling yet seductive, that when we gaze into a mirror, we may not only be seeing ourselves, but echoes of countless others entangled with us in ways unseen. The implications ripple outward into both science and metaphysics. In quantum information science, entanglement is being harnessed to create quantum computers and quantum communication systems, technologies that could transform our world. Secure communication channels immune to eavesdropping, computers capable of solving problems impossible for classical machines. All of this depends on the eerie unity revealed by entangled photons. And in each case, mirrors are indispensable tools, guiding light with absolute precision, ensuring that entanglement is preserved and measured. Yet beyond technology, entanglement forces us to confront existential questions. If distance does not matter, if separation is illusory, then perhaps consciousness itself is not confined within our skulls, but entangled with the cosmos at large. The mirror here becomes symbolic once again. When you see yourself reflected, you are not looking at an isolated individual, but at a node in a vast web of interconnection, your existence inseparable from the universe itself. The closing image of this section is cinematic and haunting. Picture two mirrors facing each other across a dark void, each sending photons outward into infinite reflections. Within those reflections, entangled pairs are born, racing away, yet never losing their invisible bond. No matter how many reflections appear, no matter how far they seem to travel, they remain tethered. The mirrors remind us of what entanglement whispers. Distance is not real. Separation is not absolute. And in the quantum world, all things are linked in a unity we can barely comprehend. Time itself, that relentless river in which we are carried from birth to death, feels like the most unyielding feature of reality. It flows forward with a certainty we never question. The past fixed, the present fleeting, the future unknown. Yet at the quantum level, mirrors begin to tell us another story. One in which time does not flow like a river at all, but loops, folds, and perhaps even reverses. In this realm, mirrors are not just reflectors of space, but reflectors of time. They become instruments through which physicists glimpse the strange possibility that causality is not one way, and that the arrow of time we depend on may be far less certain than we believe. The seed of this idea lies in quantum experiments where photons, steered by mirrors, appear to respond not only to past choices but to future ones. These are the so-called delayed choice experiments, first imagined by John Archibald Wheeler. Imagine sending a photon toward a beam splitter, which acts like a half mirror. At that moment, the photon enters a superposition, taking both paths, left and right, simultaneously. But Wheeler's twist comes later. The experimenter decides, after the photon has already passed the beam splitter, whether to recombine the paths or not. If recombined, the photon behaves as though it traveled both paths all along, creating interference. If not recombined, it behaves as though it chose one path. The paradox is haunting. The decision made in the present seems to retroactively decide what the photon did in the past. The cinematic image is staggering. Picture a photon striking a mirror, splitting into possibilities, racing down two invisible corridors. Far away, a scientist flips a switch, deciding whether those corridors will merge or remain separate. In that moment, the photon's history changes. The mirror no longer reflects light alone. It reflects the fluidity of time, bending cause and effect into something unrecognizable. The future reaches back, reshaping the past, as if the photon were waiting for us to decide what story it should tell. This challenges our deepest intuitions. We cling to the belief that the past is secure, a stone carved in permanence. Yet the delayed choice experiments suggest otherwise. They whisper that the past may be contingent, not absolute, that what we call history could be rewritten by choices not yet made. Mirrors, by splitting and guiding photons into paths that can later be recombined, become the gateways through which this unsettling truth is revealed. Even more uncanny are variations known as quantum eraser experiments. Here, photons are entangled, and mirrors direct them along paths where which path information, the knowledge of which slit or route the photon took, can be preserved or erased. If the information is preserved, no interference appears. If it is erased, even after the photon has been detected, the interference pattern reemerges. Once again, the future seems to rewrite the past. The mirror's role here is critical. It redirects entangled photons along paths that either conceal or reveal their histories, making time itself feel malleable, negotiable, uncertain. The philosophical implications are as vast as they are unsettling. If mirrors and photons can bend time's arrow, then what of us? Are we also caught in a loop where the future reshapes the past? Could choices we have not yet made ripple backward, altering the story of who we are? The idea is dizzying. That cause and effect may not be linear but entangled. That our lives may not be lines drawn from birth to death, but webs where past and future meet in shimmering uncertainty. The emotional contrast here is sharp. On one side, awe. Time, the tyrant we thought unyielding, may not be as absolute as we believed. This inspires hope that perhaps the mistakes of the past are not as final, that history is less rigid than it seems. On the other side, dread. If the past itself is unstable, then what anchor do we have? What certainty remains, if even yesterday can be rewritten by tomorrow? The mirror becomes symbolic once again, a surface that seems fixed but hides infinite possibilities trembling beneath. To imagine this cinematically, picture two mirrors facing each other across darkness, reflecting a single photon back and forth. Each reflection could represent a different timeline, one where the photon took the left path, one where it took the right. As the reflections multiply, so do the timelines, stretching backward and forward until the very distinction between past and future dissolves into endless shimmering echoes. The mirror ceases to be a boundary of space and becomes instead a boundary of time itself, a portal where histories overlap. Physicists continue to debate what these experiments mean. Some argue they do not literally rewrite the past, but reveal that past and future are not fundamental categories, only emergent features of deeper quantum laws. Others suggest that the many worlds interpretation offers a cleaner explanation. Every choice creates a branching universe, and the photon's multiple histories are real, each in its own branch. Either way, mirrors remain central, shaping the experiments that force us to question the solidity of time. As this section closes, the image that lingers is both beautiful and unsettling. A photon shimmering at a mirror surface, uncertain whether it is reflecting the past or foreshadowing the future. Each bounce is a decision not only of direction, but of history itself. And as we walk away from the mirror in our own lives, we are left with the haunting question: is the past truly behind us, or is it waiting for us in the glass, waiting for the choices we have yet to make? Consciousness has always stood as the most profound mystery, an enigma not of matter, but of experience. We can map the brain's neurons, measure the firing of synapses, trace chemical reactions across billions of connections, yet none of this explains why there is something it feels like to be alive. Why does matter, when arranged in a particular way, generate the glow of awareness? Some scientists have dared to suggest that mirrors, both literal and metaphorical, may hold key. For mirrors do not simply reflect faces, they reflect awareness itself, giving us the first undeniable evidence that I exists. When a child looks into a mirror and realizes the reflection is them, consciousness dawns in a new and startling way. This moment is cinematic. A toddler stares at the glass, perhaps brushing a hand across their cheek, then watching the reflection do the same. Suddenly, the recognition hits. They are seeing themselves. The mirror becomes a portal of self-awareness, a thin sheet of glass that transforms the human mind from mere perception into reflection. It is not simply about vision, but about identity, about the strange loop where the observer observes themselves. But what happens when this mirror is extended into the quantum realm? Some philosophers and physicists speculate that consciousness itself may be entangled with the very fabric of reality. In certain interpretations, the act of observation collapses quantum superpositions, forcing particles to choose a definite state. Does this mean that without awareness, the universe remains in a haze of possibility? If so, consciousness is not a mere byproduct of neurons. It is woven into the machinery of existence. Mirrors, by reflecting photons and thus shaping the act of observation, symbolize this intertwining. Without seeing, the photon's path is indeterminate, yet with sight, its destiny becomes fixed. There's a haunting contrast here. On one side, awe, the idea that our awareness is not isolated but fundamental, that consciousness and cosmos are inseparable. It fills us with a sense of unity, a belief that our minds are not accidents but participants in the unfolding of reality itself. On the other side, fear. If consciousness alters reality, then how fragile is the world we know? How dependent is existence on our perception? Could reality itself shimmer like a reflection, existing only so long as there is someone to behold it? Mirrors also become metaphors in philosophy of mind. They remind us that consciousness is recursive. We are not only aware, but aware of being aware. This creates what cognitive scientist Douglas Hofstadter calls a strange loop, a hall of mirrors in which self-awareness endlessly reflects back upon itself. Each thought is like a photon bouncing between mirrors, producing infinite echoes of reflection. Our identities may be nothing more than these recursive patterns, shimmering illusions generated by the brain's endless self-reflection. Yet, even if an illusion, it is the most profound illusion of all, the one that creates our sense of being. Experiments deepen this mystery. In neuroscience, the mirror test for animals has long been used to measure self-awareness. Apes, dolphins, elephants, even certain birds have shown recognition of their reflections, suggesting they too possess some degree of consciousness. Here, mirrors become diagnostic tools, windows into the hidden world of minds other than our own. But when we extend this metaphor to the universe, we arrive at a breathtaking possibility. Could the cosmos itself be conscious, its laws and structures reflections of a deeper self-awareness spread across space-time? Cinematically, one might picture the universe as a vast mirror hall, galaxies glimmering like reflections in an infinite chamber. Each consciousness, human, animal, or otherwise, is a reflection staring back, part of the greater whole. The stars themselves could be thought of as lights shining across this mirror cosmos, illuminating awareness on scales we cannot yet fathom. At the cutting edge, some theories even attempt to unite consciousness with quantum physics directly. The orchestroir theory, proposed by Roger Penrose and Stuart Hameroff, suggests that consciousness may arise from quantum processes within the microtubules of neurons. If true, this would mean awareness is not only a byproduct of biology, but is rooted in the same strange laws that govern photons and particles. Mirrors, in this sense, become symbolic bridges. The same instruments that reveal the quantum world may also hint at the origins of our inner lives. And yet, just as mirrors can deceive, showing us reversed versions of reality, so too may our theories of consciousness mislead. Perhaps the connection between mind and quantum mechanics is only metaphorical, not literal. Perhaps the universe does not require consciousness to exist, but rather, consciousness is a local phenomenon that tricks us into believing it is universal. This tension between cosmic significance and cosmic insignificance fuels the emotional weight of the question. The section ends on a haunting image. A lone figure standing before a mirror in a dark room, staring into their reflection. But instead of their own face, they see countless versions of themselves, young and old, joyful and sorrowful, alive and dead, stretching out into infinity. Each reflection is a possible self, a possible world, shimmering within the glass. The mirror is no longer merely glass and silver. It is the threshold between consciousness and cosmos, between awareness and infinity. The idea of parallel worlds has long haunted both science and myth, but in the halls of modern physics, it emerges not as fantasy, but as a serious possibility. The many-worlds interpretation of quantum mechanics proposes that every quantum event splits reality into branches. Each decision, each photon reflection, each quantum coin toss does not collapse into one outcome. It multiplies, unfurling universes like an infinite forest of possibilities. If this vision is true, then mirrors, those simple sheets of glass that divide and reflect, are uncanny symbols of this branching multiverse. For when light strikes a mirror, two paths are created: the path forward into the reflected world and the path backward into ours. Each reflection is a metaphor for a world that could exist, shimmering just beyond reach. Cinematically, imagine standing before a mirror in a darkened corridor. Behind you, your world stretches into shadow. Ahead, within the glass, another world stares back. It looks the same, but it is not yours. Tilt your head, and your reflection tilts with you. But what if, for just one moment, it did not? What if it moved on its own, hinting at an Earth where choices diverged? The mirror becomes not merely an object, but a window, a fragile boundary between worlds that may exist side by side, invisible yet real. The many-worlds interpretation was first proposed by physicist Hugh Everett in the 1950s, and though controversial at the time, it has grown into one of the most fascinating explanations of quantum mystery. Instead of particles choosing one outcome when measured, Everett argued that all outcomes happen. We experience only one because our consciousness follows a single branch. The photon that reflects off the mirror and the photon that passes through both exist, just in different universes. What feels like randomness is simply the splitting of reality into paths we cannot traverse. Mirrors capture this splitting in poetic imagery. Each reflection is a duplicate world, one that feels eerily close yet unreachable. Just as the multiverse suggests infinite Earths, mirrors suggest infinite rooms, infinite selves, infinite perspectives. The ordinary act of looking at your reflection becomes laden with metaphysical weight. Are you staring at yourself or at a version of you in another branch of existence? Could that other version be staring back, aware in some impossible way of the fracture between your worlds? Contrast deepens the drama. On one hand, awe, the possibility that reality is far richer than we imagine, that every dream, every possibility, every choice is realized somewhere. In this view, no story is ever truly lost. Every path is walked, every chance is taken, every world exists. It inspires hope, a cosmic abundance in which nothing is wasted. On the other hand, dread. If there are infinite yous, then who are you? Are you unique, or just one echo among uncountable copies? Does your life carry meaning, or is it diluted across endless variations? Mirrors, with their endless reflections, capture both wonder and terror in equal measure. Experiments with photons and mirrors hint tantalizingly at this multiplicity. When photons are split at a beam splitter, they seem to travel both paths, interfering with themselves. Some interpretations say they exist in superposition until observed, but the many worlds view insists both outcomes are real, each in its own universe. Mirrors are thus more than passive reflectors. They are symbols of quantum branching, gateways where reality itself divides. Each photon bouncing from a mirror could represent a new Earth, a new history, a new self diverging into the unseen multiverse. Philosophers seize on this imagery. If infinite Earths exist, then in some worlds your greatest triumphs are already achieved, your worst failures already endured. In others, you never existed at all. Mirrors embody this uncertainty. They reflect not just your present form, but the infinite variations that might have been. To gaze into a mirror is to confront the multiverse directly, to see not only who you are, but who you might have been. The glass holds your face, but the imagination fills it with countless others. The cinematic metaphor intensifies. Picture a hall of mirrors stretching into infinity, each pane showing a slightly different version of you. In one, you are different clothes. In another, your face bears a scar. In yet another, you're older or younger or gone entirely. The reflections are endless, branching like trees of possibility. Somewhere in that labyrinth, perhaps, is the version of you that chose differently, that lived a different story. The Hall of Mirrors becomes the multiverse made visible, overwhelming and mesmerizing. Yet science is cautious. The many worlds interpretation is not proven. It is a framework, one of many competing visions of quantum reality. Critics argue it multiplies worlds without necessity, that it explains too much without offering testable predictions. But even if unproven, it remains compelling, for it preserves the elegance of quantum equations without collapsing possibilities. And mirrors, once again, help us grasp its emotional force. For though we cannot see the other worlds, the reflection before us is a haunting reminder that what is visible may not be all that exists. The emotional heart of this section beats in contrast. Awe at infinite abundance collides with despair at infinite redundancy. If every version of you exists, does choice matter? If failure in one world is balanced by success in another, What meaning does your personal journey hold? Yet perhaps the answer lies not in seeking uniqueness, but in embracing connection, the recognition that we are threads in a cosmic tapestry far beyond comprehension. Mirrors capture this beautifully. Each reflection is both separate and linked, distinct yet dependent on the original. As this section closes, the imagery sharpens into a haunting scene. You stand before a mirror, but this time, your reflection does not mimic you perfectly. Its lips twitch into a faint smile, though yours remain still. Its eyes glimmer with secrets of choices not made, of worlds you cannot enter. The glass becomes a threshold, a reminder that beyond the fragile surface of reality may lie countless Earths, countless lives, countless yous, each shimmering like reflections in the quantum mirror of the multiverse. If the universe is truly a hall of mirrors, then what does it mean for the future of humanity? Section by section, we have followed photons bouncing through glass and possibility, each reflection revealing not only the laws of physics, but the shadows of philosophy. Now, in this turning point, the question becomes, how might these discoveries reshape the fate of our species? Mirrors have always been tools for vanity, for self-recognition, for art. But in the hands of science, they are evolving into gateways, guides for experiments in quantum mechanics, instruments in astronomy, and symbols for the most audacious visions of tomorrow. The mirror is no longer just glass. It is destiny polished into clarity. One of the most immediate frontiers is quantum technology. Already, scientists are using mirrors in delicate setups to trap, split, and guide photons with precision so exact that it borders on the surreal. Quantum computers, powered by entangled states, rely on photons whose paths are carefully manipulated by mirrors and beam splitters. In these machines, reflections are not metaphorical. They are literal, necessary steps in computations that could shatter the limits of today's technology. If successful, quantum computers will change medicine, cryptography, and artificial intelligence. They will map protein folds with ease, break codes that once seemed unbreakable, and simulate realities so complex that even our weather might finally yield to prediction. But beyond technology, mirrors point us toward a more cosmic ambition, exploration. Astronomers use vast mirrors to capture starlight traveling millions of years through space. The James Webb Space Telescope, with its golden hexagonal mirrors, does not merely reflect light. It bends it into revelation, peeling back the layers of cosmic history to the very birth of stars and galaxies. Each reflection carries the faint echoes of other Earths, hidden worlds orbiting distant suns. These mirrors act as our eyes across the void, reminding us that to look outward is also to look inward, that every reflection from a distant star is a mirror of our own beginnings. The emotional weight here is powerful. On one hand, mirrors promise hope. With them, we might decode the structure of consciousness, master quantum power, or discover habitable worlds beyond our own. On the other hand, mirrors carry warning. If every reflection reveals another possibility, then perhaps the dangers we fear, environmental collapse, technological misuse, self-destruction, are also reflected somewhere in the glass. The future is not one face, but many, each shimmering like a possibility in the mirrored corridor of time. Cinematically, one could imagine humanity standing before a giant cosmic mirror. In its surface appear countless reflections, one Earth thriving, green with renewal, another burning, its atmosphere stripped, another silent, lifeless, abandoned. Which reflection becomes our truth may depend on choices we have yet to make. The mirror reflects possibility, but it does not decide. That task is ours. Philosophically, this raises profound questions about agency. If the many worlds interpretation is true, then every choice we make splits into countless outcomes, each reflected in its own universe. Does this mean our decisions are meaningless, that all paths are taken regardless? Or does it mean that meaning lies precisely in the act of choosing, in the consciousness that walks one path, rather than another? Mirrors embody this paradox. Each reflection is real, but only one holds your gaze at a time. Similarly, our lives may be part of a vast branching tree of realities, but the branch we experience is still ours, still sacred. The symbolism extends even further. In mythology, mirrors have often been seen as portals, gateways to spirits, tools for divination, ways of glimpsing what cannot otherwise be known. In science, they're just as uncanny, showing us aspects of reality hidden to the naked eye. From telescopes that see the edges of the universe to microscopes that reveal the dance of molecules, mirrors expand the limits of perception. They remind us that our understanding of the cosmos is not bounded by our senses, but extended by our tools. In this sense, the future of humanity is inseparable from the future of mirrors, both literal and metaphorical. And yet, there is also danger in mirrors. Just as Narcissus was entranced by his reflection, humanity too risks becoming lost in its mirrored illusions, trapped in simulations, overwhelmed by infinite realities, seduced by power we do not yet understand. The mirror warns as much as it inspires. Every reflection is a temptation, every possibility a risk. Our destiny may not be determined by what mirrors reveal, but by how wisely we respond to them. As we imagine the centuries ahead, the role of mirrors seems destined only to grow. They will guide quantum networks that stretch across the planet, enabling communication that cannot be hacked. They will sit at the hearts of telescopes orbiting distant moons, catching light from stars we cannot yet name. They will probe the boundaries of consciousness, perhaps even reflecting back the secrets of a mind. And they will remain in every human home, every human life, silent reminders that to look outward is always also to look inward. The closing image of this section is cinematic and resonant. Humanity gathered before a colossal mirror floating in space, its surface reflecting not one image but thousands. In some reflections we see triumph, in others tragedy. Some shine with utopian light, others with dystopian shadow. And then, in a single frame, all the reflections dissolve into one, showing only us, fragile, uncertain, yet still standing, still choosing. The mirror does not dictate which future comes to pass. It merely shows us what could be. The choice, the reflection that will endure, belongs to us alone. In every age of human history, science has walked hand in hand with philosophy. One offers instruments, equations, and experiments. The other offers meaning, interpretation, and the framing of questions too large for data alone. When we arrive at the mystery of quantum mirrors, those strange devices that bend light, reveal entanglement, and hint at parallel worlds, we are no longer in the domain of physics alone. We are staring at questions of existence, identity, and truth. Section 16 turns toward the great dialogue between science and philosophy, showing how mirrors act not just as tools for experiments, but as metaphors in our struggle to understand who we are and where we belong. Philosophically, the mirror has always been a symbol of self-examination. Socrates urged humanity to know thyself, and the mirror embodies that imperative in physical form. To look in a glass is to see yourself reflected back. Yet philosophy reminds us that what we see is not necessarily the truth, but an image shaped by perception. Likewise, in science, mirrors do not reveal reality directly. They bend it, invert it, redirect it. This parallel is profound. Both philosophy and physics warn us that what we perceive may not be reality itself, but only a reflection of it. The cinematic image is immediate. A philosopher in ancient Greece gazes into polished bronze, seeing his face blurred and distorted. Centuries later, a physicist peers into the mirrored chamber of a quantum optics experiment, watching photons split and recombine. Both confront the same truth, that reality is slippery, elusive, more like a reflection than a solid object. Mirrors unite their quests across time, showing that science and philosophy are two sides of the same reflective surface. At the heart of their dialogue lies the problem of perception. Philosophers from Plato to Kant have warned that human senses are limited, filtering reality into forms our minds can grasp. Plato's allegory of the cave describes shadows on a wall, mistaken for truth. A mirror offers a similar illusion. It seems to show reality, but only in reverse, a copy rather than the thing itself. Modern science echoes this warning. Photons bouncing from mirrors are not the objects themselves, only their echoes in light. When quantum physics tells us particles exist in superpositions until measured, it deepens Plato's ancient concern. What we see may not be the real at all, only the reflection cast by measurement. This creates a philosophical tension between realism and idealism. Realism insists that the world exists independently of our perception, like an object standing before a mirror whether or not we look. Idealism suggests the opposite, that reality is inseparable from mind, that what we call the world is always filtered through consciousness. Quantum mirrors sharpen this debate. If photons exist as waves of possibility until observed, then perhaps reality truly is dependent on perception. On the other hand, if the many worlds interpretation is correct, all outcomes exist regardless of what we see, and the mirror merely reveals one path among infinite others. The emotional resonance of this debate is powerful. On one side lies awe, that our minds might be participants in reality's unfolding, shaping existence through observation. On the other lies fear, that we can never truly know the world as it is, only as it appears to us, reflected through the glass of perception. Science and philosophy together circle this paradox, each offering partial answers, neither resolving the mystery fully. The mirror here is both metaphor and evidence, an object that embodies the very uncertainty it helps us study. Cinematically, imagine a scene in which two figures stand on opposite sides of a vast mirror. One is a scientist, armed with lasers, equations, and detectors. The other is a philosopher, armed with questions, arguments, and metaphors. As they gaze into the glass, they see not only each other, but countless reflections stretching into infinity. In those reflections, their roles blur. The scientist becomes the philosopher the scientist. The mirror collapses their distinction, showing that both pursuits are reflections of the same desire, to grasp the hidden order of existence. Even in language, mirrors bridge science and philosophy. Scientists speak of mirror symmetry in particle physics, describing how fundamental laws might remain unchanged under reflection. Philosophers speak of mirroring in consciousness, the mind's ability to reflect upon itself. Both invoke the same imagery because both confront the same truth. Reality is recursive, self-reflecting, filled with patterns that echo across scales. The mirror becomes the universal metaphor, equally at home in equations and in poetry. The dialogue between science and philosophy is not always harmonious. At times, scientists dismiss philosophy as speculation without evidence, while philosophers critique science for its narrow focus on what can be measured. Yet the history of mirrors proves that both are essential. Without philosophy, we might mistake reflections for reality. Without science, we might never learn how reflections behave. Together, they keep us balanced between wonder and rigor, imagination and precision. The emotional arc of this section rests in contrast. On one side, we are uplifted by the idea that science and philosophy, united, can bring us closer to truth. On the other, we are sobered by the recognition that truth itself may always remain just beyond reach, like an image in a mirror that retreats as we approach. The reflection is perfect yet untouchable, reminding us that our grasp of reality may always be partial. This tension between progress and limitation, knowledge and mystery, is the heartbeat of the human quest for understanding. As this section closes, the imagery deepens into a final cinematic vision. A lone mirror standing in a desert at twilight, reflecting the sky as stars begin to appear. A philosopher approaches from one side, a scientist from the other. They both gaze into the glass and see not themselves, but the infinite cosmos stretching into its depths. For a moment, they understand that their disciplines are not rivals, but reflections, each necessary, each incomplete. The mirror does not give them the answer, but it shows them the unity of their pursuit. In that shimmering surface, science and philosophy meet, and humanity glimpses itself reflected in the mystery of the universe. Throughout our journey, mirrors have emerged as more than polished glass. They are symbols of the human condition itself. They do not only reflect photons, but reveal the hidden architecture of our fears, our hopes, our search for meaning. Section 17 turns fully to metaphor, transforming mirrors into living symbols of duality, illusion, and revelation. For every reflection we encounter is both truth and deception, comfort and threat. To understand mirrors as metaphors is to confront the paradoxes of existence, that what we see is not always what is real, that clarity often hides mystery, and that the surface of things conceals infinite depths. From the earliest myths, mirrors have been associated with deception and hidden truths. In folklore, mirrors are portals to other realms, gateways through which spirits might cross. In fairy tales, they speak truths no human dares utter. Mirror, mirror on the wall. In horror, mirrors reveal what should remain unseen, ghosts, doubles, or darker versions of ourselves. Culturally, mirrors have always been both trusted and feared, their smooth surface a veil between worlds. This duality finds its echo in modern science. Just as folklore warns that mirrors can trick the eye, quantum experiments remind us that reality itself can trick the mind. Superpositions, entanglement, delayed choice experiments all suggest that what we see may not be the whole truth, only a reflection filtered by our perception. Cinematically, imagine walking through a vast hall of mirrors, your reflection multiplying endlessly in every direction. At first, it is mesmerizing, an affirmation of existence. But then, unease creeps in. Which reflection is truly you? What if one moves differently, lagging behind or surging ahead? The metaphor is sharp. Our lives are filled with reflections, memories, identities, choices that may or may not align with who we believe ourselves to be. Mirrors remind us of this fragility, the instability of selfhood. Philosophers have long used mirrors to describe the human mind. Descartes envisioned the self as a reflective consciousness, certain only of its own awareness. Jung spoke of the shadow self, the parts of us mirrored in dreams and projections, unseen yet present. In Eastern traditions, the mind is often compared to a mirror clouded by dust. Enlightenment comes not by adding knowledge, but by polishing away the illusions. These metaphors resonate with science as well. In physics, mirrors do not alter light. They only redirect it. Likewise, our minds may not create reality, but reflect it, sometimes clearly, sometimes distorted. The emotional contrast here is powerful. On one side lies hope. Mirrors symbolize self-awareness, the ability to see ourselves clearly, to reflect upon existence and grow. They offer revelation, a chance to confront who we are and who we might become. On the other side lies dread. Mirrors symbolize illusion, the possibility that everything we know is but a reflection, a copy of a deeper reality forever hidden. Are we seeing truth or only shadows dancing on glass? This tension fuels the fascination mirrors hold over us, both in myth and in science. Even language bears the weight of this metaphor. We speak of mirror neurons, cells in the brain that reflect the actions of others, allowing empathy. We say that art mirrors life, that history is a mirror of human nature. These uses are not accidents, but reflections of a deeper truth. Mirrors are our most natural metaphor for connection, imitation, and understanding. They reveal that we are beings who see ourselves in others, who understand the world by reflecting it inward. Science itself leans on this metaphor. In cosmology, the structure of the universe is sometimes described as self-similar, like reflections repeating at different scales. In particle physics, concepts of symmetry often rely on mirror operations, revealing that nature itself may be built upon reflection. Even black holes, with their event horizons, are sometimes likened to mirrors, surfaces beyond which light cannot escape, showing us not what lies beyond, but only the reflection of our own limits. The cinematic imagery intensifies. Picture a mirror floating in deep space, reflecting not stars, but endless versions of Earth. Some are verdant, alive with flourishing civilizations. Others are barren, silent, long extinct. Each reflection is a metaphor for possibility, a reminder that our world, too, is only one of many potential outcomes. The mirror does not choose, it only shows. The meaning lies in what we do with what we see. The metaphor of the mirror also invites us to confront mortality. Just as a reflection vanishes when the light is gone, so too does life seem fleeting, a brief shimmer against eternity. Yet within that shimmer lies beauty. A reflection may be temporary, but it testifies that something was there, something real. In this sense, mirrors become symbols of memory, of legacy, of the fragile but luminous presence of being. The emotional climax of this section is contrast itself, the mirror as savior and as deceiver, as truth and as lie, as revelation and as illusion. This duality mirrors the human condition. We are creatures who seek clarity yet are bound by limits, who long for truth but live in reflections. The mirror embodies this paradox, holding both hope and dread in its polished surface. The closing image is haunting and unforgettable. A person alone in a darkened room, facing a mirror. They expect to see themselves, but the reflection stares back with a subtle difference. Eyes too knowing, a smile too sharp. In that moment, the metaphor becomes real. The mirror reveals not only who we are, but who we might fear to be. It is both a warning and a gift, reminding us that every reflection is a chance for self-discovery, but also a reminder that the truth may never be fully ours to grasp. The journey through quantum mirrors, parallel worlds, and entangled photons culminates in a realization that is both exhilarating and humbling. We stand on the threshold of understanding reality in ways that were once unimaginable. Section 18 serves as the grand synthesis, weaving together the threads of science, philosophy, and metaphor into a vision of existence that is as cinematic as it is profound. Here, mirrors are no longer merely instruments of physics or objects of reflection. They are symbols of humanity's relentless curiosity, our desire to grasp the infinite, and our confrontation with the ultimate mystery, the nature of reality itself. Consider a photon traveling through a laboratory filled with mirrors. It bounces, splits, recombines, interferes, and entangles. Every reflection is a possibility, every path a branching universe. On the surface, this is a story of particles and light. But beneath that, it is a story of humans seeking to understand our place in the cosmos. Every experiment, every observation, is a reflection of our own drive to know, to explore, to illuminate the darkness of the unknown. Mirrors, in this sense, are extensions of our curiosity. They take our questions and cast them across the universe, revealing answers we could not see otherwise. The cinematic imagery is powerful. Imagine a vast hall of mirrors stretching into infinity, each pane reflecting a slightly different reality. Some mirrors show Earth thriving in green abundance. Others reveal a world scarred by catastrophe. Some show a solitary figure, others a crowd, yet all reflections shimmer with life. Within these mirrors, every possibility of existence is captured, and yet the observer can only focus on one reflection at a time. The mirrors, like quantum experiments, reveal the multiplicity of reality, while also highlighting the limitations of perception. Science provides the tools to probe, this multiplicity. Quantum experiments with mirrors, beam splitters, and entangled photons allow us to glimpse phenomena that defy classical logic. Delayed choice experiments where the future seems to influence the past, quantum erasers that restore interference patterns after measurement, and entangled particles that remain connected across vast distances. Each setup is a cinematic story, a choreography of light and reflection, revealing layers of reality that are otherwise invisible. These experiments are not just academic. They push the boundaries of technology, computation, and our understanding of consciousness itself. Philosophy provides the lens to interpret these revelations. As mirrors reflect light, they also reflect thought. Every reflection, every branching possibility, forces us to ask, what is real? What is perception? What does it mean to exist? If the universe is a hall of mirrors, then perhaps consciousness itself is the observer that defines the paths of reality. Are we merely witnesses, or are we co-creators of the worlds we inhabit? Mirrors bridge these domains, serving both as literal tools of science and as metaphors for self-awareness and cosmic inquiry. Emotionally, this synthesis carries both awe and humility. Awe at the richness of existence, the infinite possibilities suggested by quantum mechanics, the depth of the multiverse, and the elegance of mirrors guiding photons across branching paths. Humility in recognizing the limits of our perception, the fragility of knowledge, and the fact that reality may be far more complex than our minds can fully grasp. The mirrors remind us that for all our observation, all our measurement, the universe retains its mystery, shimmering just beyond comprehension. Cinematically, imagine the final image. A lone figure stepping into a mirrored chamber, surrounded by infinite reflections of themselves, the photon pathways visible as streaks of light dancing across glass surfaces. Each reflection represents a choice, a path, a world. As the figure moves, the reflections shift, multiply, and shimmer. The scene captures the essence of human existence, conscious, curious, striving to understand, yet always facing the infinite unknown. The mirrors are not obstacles. They are guides, revealing the beauty and complexity of the cosmos, while also reflecting our own inner journey. Technologically, the implications are staggering. Quantum mirrors and entanglement experiments pave the way for quantum computing, secure global communication, and perhaps even new forms of energy and observation. Mirrors allow us to manipulate light and matter at the smallest scales, harnessing phenomena that once seemed purely theoretical. These advances, in turn, expand the realm of possibility for human civilization, offering glimpses of futures once confined to imagination. Philosophically, the mirrors call upon us to reflect on responsibility. If every choice creates a branching reality, then what we do matters not only in our own world, but, metaphorically, across countless others. Each reflection is a lesson in the consequences of action, the weight of observation, and the interconnection of existence. Mirrors compel us to confront ethical, existential, and metaphysical questions. How should we live knowing that every moment is a node in an infinite network of possibility? The emotional climax is one of wonder, tempered by reflection. The mirrors show not only the grandeur of the cosmos, but the fragility of life, the beauty of curiosity, and the persistent drive to understand. They remind us that science and philosophy, technology and metaphor, observation and imagination are all intertwined. The universe is not a flat surface to be surveyed, but a hall of mirrors, infinite, complex, and breathtakingly beautiful. As the section closes, the final cinematic image lingers. The lone figure steps back from the mirrors, photons glittering like stars across glass surfaces, reflections of Earth's both real and possible shimmering around them. They are a witness to the infinite, yet grounded in their own reality. In this reflection, the journey of science, philosophy, and human curiosity converges. Mirrors do not simply reflect. They reveal. They reveal possibility, consciousness, and the infinite complexity of existence. And in the quiet glow of countless reflections, one truth emerges. The universe is far stranger, far more beautiful, and far more alive than we have ever imagined. And through our observation, we are inextricably part of its story. The quest to understand mirrors, quantum phenomena, and parallel worlds inevitably leads to a contemplation of perception itself, how we experience reality, and what it means to be conscious within it. Section 19 focuses on the profound implications for human perception, bridging science, philosophy, and the intimate experience of being alive. Mirrors, both literal and metaphorical, act as intermediaries between the external universe and our inner consciousness. They force us to confront the unsettling truth that what we see, hear, and measure is filtered through layers of observation, interpretation, and expectation, and that reality may always be more vast than our senses can grasp. At the most immediate level, mirrors shape perception in the simplest of ways. When you look at a reflection, you see yourself reversed, a perfect copy yet subtly distorted. This is an everyday metaphor for how our senses distort reality. In the quantum realm, this distortion is not metaphorical, it is literal. Photons can exist in multiple states until observed, and the very act of measurement collapses possibilities into a single outcome. Mirrors, beam splitters, and detectors shape the path of these photons, influencing what becomes real in a measurable sense. Just as we see only one reflection in a mirror at a time, we perceive only one reality, even though quantum mechanics suggests a vast multiplicity of states exist simultaneously. Cinematically, imagine a figure standing in front of a mirror that stretches to infinity. Each reflection is slightly different. In one, the figure is older, in another, younger, in another, moving in a direction the original figure never chose. This visual is more than spectacle. It is a metaphor for perception itself. Our consciousness picks one path to follow, one reality to inhabit, while the other possibilities flicker at the edges of existence. Mirrors make visible what our senses and minds often hide, that reality is fluid, that perception is selective, and that even the act of seeing is intertwined with the act of defining what is real. Philosophically, this challenges long-held assumptions about objectivity. Classical science assumed the world existed independently of observers, like a room whose contents are fixed whether or not anyone looks. Quantum physics, particularly in experiments involving mirrors, suggests otherwise. Observation is not passive but participatory. The observer interacts with reality, shaping outcomes in ways subtle yet profound. Mirrors, then, symbolize the dual role of perception. They show us the world, yet they also shape it. What we experience is inseparable from how we observe, and consciousness itself becomes an active component of reality. Emotionally, this duality generates awe and anxiety. Awe comes from recognizing that the mind is not merely a passive receptor, but a creative agent in the unfolding of the universe. Anxiety arises from the realization that our perception is limited and that the reality we inhabit may be only one layer among many. Mirrors capture this tension perfectly. They provide clarity while simultaneously hinting at hidden depths, showing a surface that is familiar yet concealing infinite possibilities beneath. The neuroscientific perspective deepens this understanding. Studies of mirror neurons, for example, reveal that our brains literally reflect the actions and emotions of others, allowing empathy and social learning. In a way, our consciousness is a mirror of the world, simultaneously perceiving and resonating with it. This internal mirroring is mirrored externally in the way quantum mirrors influence photons and experimental outcomes. The same principle repeats across scales. Reflection is both literal and figurative, shaping experience from the tiniest particle to the mind contemplating its own reflection. Cinematically, one might envision consciousness as a hall of mirrors within the brain, where thoughts, memories, and sensory inputs bounce endlessly, combining, splitting, and recombining until a coherent perception emerges. Each reflection contributes to the experience of self, yet no single mirror holds the whole truth. This metaphor extends to the universe itself. Just as photons' paths depend on mirrors, so too does our perception depend on the complex, dynamic interplay of neurons, consciousness, and environment. Reality, as we know it, is a reflection of both the external world and the internal observer. The emotional contrast deepens when considering the implications for human experience. On one side is empowerment. Understanding that perception shapes reality suggests agency, creativity, and participation in the cosmos. On the other side lies humility. No matter how advanced our instruments or theories, our view is always partial, filtered through mirrors both literal and cognitive. Every act of observation is simultaneously an act of selection, collapsing infinite possibilities into the one reality we inhabit. Finally, mirrors encourage introspection on a personal level. When we gaze into a literal mirror, we are confronted with ourselves, our choices, and our fleeting presence in the world. When we consider quantum mirrors, entanglement, and parallel worlds, the reflection becomes a meditation on existence itself. Who are we in the vast network of possibilities? How does our perception shape not only our understanding, but the unfolding of reality itself? The interplay between observation and reflection reminds us that consciousness is both observer and participant, witnessing the universe while simultaneously taking part in its creation. The closing cinematic image lingers, a lone figure in a dark room surrounded by mirrors, each reflecting slightly different versions of themselves. The reflections flicker, merge, and split, symbolizing infinite possibilities, quantum superpositions, and a multiplicity of perception. The figure reaches toward one reflection, aware that touching it may not alter it, but knowing that the act of choice, the act of observation, creates a reality uniquely theirs. In this hall of mirrors, perception and existence are intertwined, revealing the profound truth. To observe is to participate, to reflect is to know, and reality itself is inseparable from the conscious mind that beholds it.